Cephalosporins are antibiotics which got their name from a mold known as Cephalosporium, from which they were originally extracted. They belong to the pharmacological group of beta-lactam antibiotics. What all beta-lactams have in common is a beta-lactam ring in their structure, which gives them their name, and also the mechanism of action, which is the inhibition of cell wall synthesis in bacteria. So our body consists of multiple eukaryotic cells, while bacteria are prokaryotic, meaning they're primitive, single-cellular organisms. Most have a slimy capsule made out of polysaccharides and a cell wall which encapsulates and protects the bacteria like a suit of armor, and offers structural support. Bacterial cell walls are made of a substance called peptidoglycan, or murein. Peptidoglycan is a molecule composed of long strands of amino polysaccharides running in parallel. These are made of segments of N-acetylglucosamine, or NAG, and N-acetylmuramic acid, or NAM, in an alternating pattern, so NAG, NAM, NAG, NAM, and so on, like a pearl necklace. At the tips of and protruding from the NAM subunits are tetrapeptide and pentapeptide chains. These peptide chains can link to other peptide chains from the neighboring strands through a process known as transpeptidation. This is carried out by an enzyme called DD transpeptidase, or penicillin binding proteins, or PBPs. Now, these enzymes are like locks, and there are specific binding areas for the pentapeptide keys to fit into. Once the key goes in the lock, the PBP enzymes fuse them together, creating a stable link between the two amino polysaccharide strands, and strengthening the cell wall. In essence, all beta-lactam antibiotics, like the penicillins, somewhat resemble the tetrapeptide chains. Inside the bacteria, PBP enzymes will mistakenly bind to the beta-lactam antibiotic molecule, instead of a tetrapeptide, and stick inside the PBP forever, like putting chewing gum in a keyhole, permanently disabling it. As more and more PBPs get disabled, the cross-linking fails to happen, and the wall becomes weak and unstable. If the affected bacteria attempts to divide, their cell wall will collapse, killing them in the process. Now, some bacteria have developed resistance to beta-lactam antibiotics. The most notable is the notorious Staphylococcus aureus, which evolved to have enzymes called beta-lactamases or penicillinases that break down the beta-lactam ring within the antibiotic, rendering it ineffective. In response, though, we started adding beta-lactamase inhibitors, like clavulanic acid, that would bind to beta-lactamases and inactivate them, again like the gum into a keyhole. Another approach was to create new kinds of beta-lactam antibiotics, like methicillin, which has a large side chain that wouldn't fit into the keyhole of the beta-lactamase. These did work pretty well, until some Staphylococcus aureus developed PBP site mutations that changed the shape of the keyhole. So even if beta-lactamase enzymes can't break down these antibiotics, they won't fit into the PBP enzyme and thus won't work. We call these bacteria methicillin-resistant Staphylococcus aureus, or MRSA. This poses a huge problem, because it makes MRSA virtually untreatable by beta-lactam antibiotics. To treat MRSA, we resort to so-called reserve antibiotics belonging to the glycopeptide antibiotics, like vancomycin and teicoplanin. But even that might come to an end, as MRSA is also developing vancomycin resistance, becoming VRSA. Cephalosporins are a very versatile group of antibiotics, and new members of the family get discovered all the time. Cephalosporins are usually classified into loose generations, depending on their usage profile, or simply put, what they're effective against. It's important to know that generations are not age-related. There are currently 5 generations of cephalosporins. The first generation has the narrowest spectrum, and is mainly used to treat gram-positive bacteria. And generally, each successive generation expands the spectrum to treat a wider variety of bacteria. Alright, so let's make a simple and fun mnemonic that'll help you efficiently memorize and retain all these crazy farm facts. So let's imagine an apartment complex with 3 rooms in a row. The first room is pretty dilapidated, and the tenants represent the first and second gen. The second room is just average, and the tenants represent third and fourth gen, which are broad spectrum. The 5th gen gets the fanciest room, since it's the broad spectrum and it could even treat MRSA. So the 1st gen cephalosporins, like cephalexin and cefazolin, are useful against gram-positive bacteria. They're effective against streptococcus and staphylococcus that cause skin infections, and they're also taken prophylactically to prevent infections from surgical procedures. However, they're only effective against staphylococcus that have not yet evolved beta-lactamases. They're also effective against a few gram-negative bacteria that cause urinary tract infections, like Proteus mirabilis, Escherichia coli, and Klebsiella pneumoniae. Now let's go back to our apartment complex mnemonic. On one side of the dilapidated room, we have the 1st gen cephalosporins, represented by Alexander the Great, Cephalexin, playing the violin, cefazolin. Since he's horrible at it, there's a lot of people in here complaining, which represent the bacteria. First, we have a protester holding up a protest sign for Proteus. Next is an annoyed border collie for E. coli. Then there's a very angry person carrying a large club, Klebsiella. All 3 of them are waiting by the bathroom because they cause urinary tract infections. The final person is a surgeon, representing surgical prophylaxis, and he's scratching himself all over because he has skin infections. Next are the 2nd generation cephalosporins, which include cefaclor, cefprozil, cefuroxime, cefodotan, and cefoxidin. These medications are like an upgrade over 1st generation cephalosporins. First, they're more resistant to beta-lactamase. Second, they have comparable effectiveness for treating gram-positive bugs, and they cover more gram-negative bugs. These include Haemophilus influenzae, Serratia marcescens, Enterobacter aerogenes, and some Neisseria species. In addition, cefotetin and cefoxidin are the only cephalosporins that can treat anaerobic bacteria like Bacteroides fragilis, which causes peritonitis. Going back to the mnemonic, we'll put the 2nd gen cephalosporins on the other side of the dilapidated room. These medications will be represented by a falcon, for cefaclor, wearing a furry coat, for cefuroxime, eating a giant pretzel, or cefprozil. He's got a pet fox, cefoxidin, which is peeking out from a giant teacup, cefotetin. For the bugs, remember 2nd gen can treat all the bacteria covered by the 1st gen, plus a few more. So on the floor, there's a tiny vampire bat for Haemophilus, since hemo means blood and philus means like. Let's also add in a tiny Loch Ness monster for Neisseria. The 2 of them are fighting over a sausage, which represents Enterobacter, since entero means intestine, which is what sausages are made of. To divide it up, they're using a saw for Serratia, since serrated means saw-like. Finally, cefoxidin and cefotetin are the only cephalosporins used against anaerobic bacteria. So let's use a fishbowl full of water to represent a low oxygen environment. We can put an angry bacteria on steroids in there for Bacteroides. This is what's scaring the fox and causing him to hide in the teacup. Moving on to the 3rd generation cephalosporins, which include cefixime, ceftriaxone, cefotaxime, and ceftazidime. These are broad-spectrum antibiotics which improves anti-gram-negative activity at the cost of decreased efficiency against gram-positive bacteria. These cephalosporins can cross the blood-brain barrier, making them first-line treatment for bacterial meningitis, which can be caused by Haemophilus influenzae, pneumococci, meningococci, and Neisseria species. Nowadays, 3rd gen cephalosporins are also the antibiotic of choice against penicillin-resistant Neisseria gonorrhoeae. In addition, ceftazidime is effective in treating Pseudomonas aeruginosa, a bacteria so hardcore and resilient, it swims laps in hand disinfectant just to wake up in the morning. Ceftriaxone is effective in treating Borrelia burgdorferi, which causes Lyme disease. Again, back to the mnemonic. We're in the 2nd room now, and the medications in here are broad spectrum. Let's put a lot of books in here because the medications in this room can get to the brain, kind of like knowledge. For the 3rd gen medications, we have a mechanic living here to represent cefixime. He's working on fixing a taxi representing cefotaxime. The taxi's in for repair because there's an axe with 3 heads stuck in the windshield for ceftriaxone. The mechanic was paid with a giant dime for ceftazidime. To help you remember what this class of medication treats, we can use the mechanic's old memorabilia from high school. On a shelf, there's his high school football helmet, with a flame logo on it to represent meningitis. And below it is the gong he played in band, representing gonorrhea. Now, ceftazidime is special, since it's the only 3rd-gen cephalosporin that could treat Pseudomonas aeruginosa. So if you flip the dime over, it has the face of the Mona Lisa. Ceftriaxone can be used to treat Lyme disease, which is spread by ticks. So let's have the triangular axe smash a giant tick against the windshield. Next are the 4th-generation cephalosporins, which are an upgrade over the 3rd-gen, and have an even wider spectrum of activity. The main medication in this class is cefepime, which is just as effective against gram-negative bacteria as the 3rd-gen cephalosporins. Plus, it's also comparable to 1st-gen when it comes to gram-positive infections. It's also effective against Pseudomonas, and it also crosses the blood-brain barrier. Cefepime is often used to treat the same infections as the 3rd-gen, like meningitis. It's also more resistant to beta-lactamases than any other cephalosporin, so they're often used to treat nosocomial bacterial infections, or infections originating from the hospital. However, cefepime is still ineffective against MRSA, just like the other cephalosporins. Back to the mnemonic. The main 4th-gen cephalosporin in the US is cefepime, which will be represented by a primate, so we'll use a gorilla. It shares the room with the mechanic, so it can be used to treat many of the same infections as the 3rd-gen. It's also effective against Pseudomonas, so let's have him paint a picture of the Mona Lisa, except she's in a hospital bed to represent nosocomial infections. Finally, we get to the 5th generation of cephalosporins, and the main medication in this class is ceftaroline. This is also a broad-spectrum antibiotic, but it does not cross the blood-brain barrier. It's effective against those pesky Pseudomonas, but more importantly, it's one of the few medications that can treat MRSA. For the mnemonic, let's move to the last and nicest room. 5th gen is so amazing. It gets the room all for itself. Let's have a kid jumping on a trampoline to represent ceftaroline. He's super rich, so he's got the original Mona Lisa hanging in his room for the Pseudomonas. He also bought the Mars rover, representing MRSA. Adverse drug reactions related to cephalosporins are usually mild and unspecific, including diarrhea, nausea, rash, and tenderness at the injection site. These medications can cause disulfiram-like reaction. If alcohol is consumed while taking cephalosporin, the person might experience nausea, flushing, and rapid heartbeat. There's also cross-reactivity between penicillin and cephalosporin. So if someone took penicillin, they can develop an allergy to both penicillin and cephalosporin. As the last part of the mnemonic, let's put an emergency exit at the back of the apartment complex. Blocking the door are 2 pens forming a cross, to represent cross-reactivity with penicillin. In front of the door are a few empty beer bottles, to represent disulfiram reaction. Alright, as a quick recap. Cephalosporins are bactericidal antibiotics, and members of the beta-lactam antibiotic family which inhibit cell wall synthesis. There are 5 generations of cephalosporins. 1st-gen medications are usually used to treat gram-positive infections, UTIs, caused by a few gram-negative bacteria, and as prophylaxis before surgery. 2nd-gen can treat a wider variety of gram-negative bacteria, and some are effective against anaerobes. Generation 3 and 4 are wide-spectrum, and cross the blood-brain barrier, making them the first-line treatment for bacterial meningitis. Ceftriaxone from the 3rd gen and cefepime from the 4th gen are also effective against Pseudomonas. Gen 5 is also wide-spectrum but does not cross the blood-brain barrier. It's the only class of cephalosporins effective against both Pseudomonas and MRSA. But wait, there's more. Here's a mind map with all of the mnemonics from the video. Go ahead and pause the video so you can test yourself to see what you remember. Stay tuned for the answers at the end.